This video is all about how we can use these addition formulae to solve trigonometric equations. So you should have got these formulae copied down from a previous video, but if you haven't yet, make sure you copy them down now. We're going to do two slightly different examples of how we can use these to solve equations. So here's the first one we're going to do. The reason why we have to use the addition formulae for this question is because notice that the inside of our cos function is completely different to the inside of the sine function. So the way these are written at the moment, there is no way I can combine these two trigonometric functions together. So I have to expand these brackets. I've got no choice. So let's get going with expanding them. So I'm going to leave this 3 at the front here. The cos 2 theta plus 60 is going to become cos 2 theta cos 60 minus sine 2 theta sine 60. So this is me expanding this bracket to get this. Next, I've got the minus, and now I want to expand this sine here. And so that's going to give me sine 2 theta cos 30 minus cos 2 theta sine 30. Right, next, let's expand these brackets. So I will get 3 lots of cos 2 theta cos 60 minus 3 lots of sine 2 theta sine 60. Then I've got the minus sine 2 theta cos 30, and then the minus and the minus will make this next term a plus cos 2 theta sine 30. Now, there's a number of terms here, a number of actual numerical answers that I could just actually work out. I know that cos 60 is a half. I know that sine 60 is root 3 over 2. I know that cos 30 is root 3 over 2. And I know that sine 30 is 1/2. So let me just write those in just above. I know that this is root 3 over 2. I know that that's 1/2. I know this is root 3 over 2. I know this is root 3 over 2. And I know that this is a half. So this first term, this here, the 3 times cos 2 theta times a half is going to be 3 over 2 cos 2 theta. Then I've got the 3 times root 3 over 2 sine 2 theta minus root 3 over 2 sine 2 theta plus 1/2 cos 2 theta. Now there's a lot of 2's here. We've got a 2 on the denominator of each of these fractions. So I'm going to times everything by 2. I'm going to cancel all of those out just to make my life a little bit easier. To get 3 cos 2 theta minus 3 root 3 sine 2 theta minus root 3 sine 2 theta plus cos 2 theta. Now, we also notice that we've got some like terms. You may have spotted these already. I've got the 3 cos 2 theta plus cos 2 theta, which is going to give me 4 cos 2 theta. Also note that I've got minus 3 root 3 sine 2 theta minus root 3 sine 2 theta. So collecting those together would give minus 4 root 3 sine 2 theta. Okay, this is looking much simpler now. Let me just create a bit more space and then we'll carry on. Right, next job. I could divide everything through by cos 2 theta at this stage. That way I would end up with a tan 2 theta. So 4 cos 2 theta divided by cos 2 theta equals 4. The sine 2 theta divided by cos 2 theta is tan 2 theta. I'm now going to rearrange to make the tan 2 theta the subject. So tan 2 theta is going to equal 1 over root 3. Right, I now want to do tan inverse of both sides. Now, when I do that, I get 30 degrees, but that's not the only answer. Remember, whenever we do sine inverse, cos inverse, tan inverse, there is always an infinite number of solutions. So I'm going to have to draw the graph. Notice that I want solutions between 0 and 360. But I'm actually going to draw the graph between 0 and 720. The reason why I'm going up to 720, the reason why I'm doubling my graph is quite simply because I know at the end, when I get to the very end of this problem, I'm going to divide all my answers by 2 because of that 2 theta there. So because I know I'm going to divide all my answers by 2, I actually want to draw my graph all the way up to 720 to get all the solutions up to 720, so that when I divide them all by 2, it will give me all the answers between 0 and 360. Excuse me. Okay, so my first answer was 30, which was about here. So there'll be another answer here, another answer here, another answer here. That's 30. So this has to be 30, this has to be 30, this has to be 30. So I now want to do 180 plus 30, 360 plus 30, and 540 plus 30. Now I have all my answers. I'm going to divide them all by 2. To get my 4 solutions that are all between 0 and 360. So there we go. That's one example. Second example. Now, part A is actually a question that we could have done from the last video. We could have done this on the last sheet. And in fact, you did do this on the last sheet a lot. So I'm not planning on redoing part A at all. You should be pretty fluent with doing part A. It says to express root 3 cos x minus sine x in the form of r cos x plus alpha, where r is bigger than 0 and alpha is between 0 and pi over 2. Like I say, we should be pretty used to doing these from the last sheet. So I'm just going to tell you that if you do this, you get 2 cos x plus pi over 6. So now we've done that in part A. The main bit here is we're going to use that to solve an equation. So notice that the left-hand side here is what we had in part A. So I could replace that with this r cos x plus a. So that's what I'm going to do. The left-hand side here, I'm going to replace with 2 cos x plus pi over 6. And I know I want to solve it when that's equal to 1. I can now divide both sides of this equation by the 2 to get cos x plus pi over 6 is equal to 1/2. I can now do cos inverse. Cos inverse of 1/2 is pi over 3. Or, remember that whenever you do cos inverse, you're going to have to draw the graph to find the other solutions. I'm just going to draw the graph between 0 and 2 pi. So my first solution, pi over 3, is roughly here somewhere. There'd be a second solution over here. If this is pi over 3, then this is pi over 3 by symmetry. Therefore, to get to this angle, I must do 2 pi minus pi over 3, which is going to be 5 pi over 3. So I know that x plus pi over 6 is either going to equal pi over 3 or 5 pi over 3. So now all I need to do is take pi over 6 away from both of those, and that's going to give me the 2 answers that I want. So pi over 3 minus pi over 6 is going to be pi over 6, and 5 pi over 3 minus pi over 6 is going to be 3 pi over 2. And those are your 2 answers. So 2 examples there of how we can use the addition formulae to solve trigonometric equations. If we have a cos x plus sine x or cos x minus sine x or any combinations like that, then this example here is a good way of doing it. If we have an example where the insides are completely different, of the trigonometric functions are completely different, then expanding them is a good way to go.